Welcome back in, everyone. We're going to be covering the SI prefixes today. Basically, nano, milli, all of that fun stuff. I'm sure you guys are really excited to get into this. But basically, we're just going to talk about what the prefixes are and how to essentially make those conversions from whatever unit they give you to the standard unit significantly easier, right? So we're going to start off just by listing the prefixes. We're only going to do the prefixes that are smaller than 10 to the 0th power, which would be like meters. Meters is a 10 to the 0th power unit, meaning that it's basically just the standard unit, essentially. So we're only going to be starting off with things that are smaller, and we're going to use meters as the example. Using meters as an example. So the prefixes, we're going to start off on the left. That we're going to write. We'll do nano first. We have nano, which is in parentheses just a little n. Micro, which is going to be the Greek symbol mu, kind of like we have in friction. Then we have milli, which is just going to be a lowercase m. Then we have centi, which is just going to be a C, and then we just have normal meters, right? Okay, so whenever we are going from nano to meters, basically whenever we do this conversion, see if I can get this arrow right. Whenever we go from nano to meters, I basically want you to be asking yourself, is this number going to be bigger or smaller? So for example, if you have 200 nanometers, if you convert that to meters, is the number of meters going to be larger or smaller? And the answer to that is it's going to be smaller. A meter is a larger unit than a nanometer, meaning that whenever we're going from nanometers to meters, the number itself is going to get smaller. So for example, 100 nanometers would be equal to 100 times 10 to the power of -9 meters, or 1 times 10 to the -7th meters. Right? So basically, this is telling you essentially that nano, in order to get from nano to meters, we have to multiply by 10 to the -9th. We're getting smaller. And if we're going backwards, if we're trying to get from meters to nanometers, like maybe this nanometers is something we commonly see with the waves. If we're trying to go backwards, this number is actually going to get bigger because there's a lot more nanometers than there are in meters. So in this case, we would be multiplying it by 10 to the power of 9, not -9 this time, to the power of 9. We could also theoretically divide by 10 to the power of -9. It's going to cancel out all the negatives with an inverse exponents and stuff like that. Don't worry about that. I think it's easier just to keep everything as a multiplication, where if you're going from nano to meters, the number should be getting smaller. So that's what I mean by getting smaller right there. The number should be getting smaller, so you multiply by 10 to the -9th. I'll clarify that really quickly here. That whenever we say nanometers, it's specifically the number. In this first conversion, it's specifically that the number should be getting smaller. So then down here, same thing, the number should be getting bigger. Whenever we're going from meters to nanometers. Okay, so then we can do the exact same thing for micro, but the only thing that's going to change is the exponent. So whenever we're going from micro to meters, let me space this out really quickly. Whenever we're going from micro to meters, a micrometer is smaller than a meter. So therefore, because of that, our number is going to be getting smaller. And then whenever we're going from meter to micrometer, it's going to get bigger. So I'm quite literally just going to copy and paste what we have right here, which I cannot do. So I lied. I'm going to write out the whole thing. Whenever we're going from micrometers to meters, the number is going to be getting smaller, this time just by a factor of 10 to the -6th. The number is getting smaller. That's how we can get to meters. And then if we're going the opposite direction, just like we just talked about, the number is going to get bigger because there's a larger number of micrometers in a meter. There's a micrometer is smaller than a meter. So if we're converting from meters to micrometers, there's going to be a lot more micrometer. I don't know. I think you understand what I'm trying to get at. I'm confusing myself with these semantics here. As long as you understand that whenever we're going from one of these smaller SI prefixes to meters, your number needs to be getting smaller. That's why we're using the negative exponent. Whenever going the opposite direction, the number is going to get bigger, which is why we're using the positive one. One thing I will say while I'm writing all of this out is I do have a web app, which basically it's just like a quick little quiz game. It's free that you can use that has all of these conversions, and it will test stuff like this. Like whenever we're going from meters to micrometers, how much bigger or smaller is the number going to get, so on and so forth, for you to check that knowledge. Okay, same exact thing for millimeters. Whenever we're going from millimeters to meters, the number is going to be getting smaller just by now a factor of 10 to the negative third. Smaller until we get to meters, and then if we're going the opposite direction, of course, the number is going to get bigger, right? Same exact thing, just now with a different exponent. 10 to the power of 3, the number is going to get bigger. And finally, we have centimeters. Realistically, in the real world, this is probably the prefix that people have the most exposure to, since centimeters is a pretty common SI unit of measurement. So whenever we're going from centimeters to meters, there's 100 centimeters in every meter, basically stating that every centimeter is 1 times 10 to the negative second meters. So if we're going from centimeters to meters, we have to make this number smaller by a factor of 10 to the negative second. And whenever I go the reverse direction, the number is going to be getting larger. So it's going to be a positive exponent. We're not changing the number. We're just changing whether it's positive or negative to make the number bigger or smaller. So this one, the number is getting bigger. All right, so these are the SI prefixes. These are specifically the ones that are smaller than meters. These are the only ones that I recommend memorizing for the MCAT, with the exception of the units that are larger than meters, which we're going to do that at the end here. But basically, this is just an easy way to do MCAT math, because obviously a lot of things they're going to give you nanometers, but the equations that we're using don't use nanometers, they use meters. So we'll need to do that conversion, right? So really quickly, recommend screenshotting this if this is something that you need to memorize. I also have that web app that can help you memorize it as well. But we're going to do a quick example. We're going to do a quick little example right here that will just say that essentially in order to calculate the energy of the wave, we are going to have to convert 350 nanometers to meters. Right? So in order to do this, you have to ask yourself, are we getting smaller or bigger going from nanometers to meters? So meters is a larger unit of measurement, meaning that the number is going to get smaller, right? Okay, so because of that, all we have to do is just memorize that nano is 10 to the 9th power, and since it's getting smaller, it will specifically be 10 to the negative 9th power. So 350 nanometers is equivalent of 350 times 10 to the negative 9th meters. Notice that basically all we did was we substituted this nano out for that little scientific notation that we talked about on the last slide. So from here, you could simplify if you wanted to. If you really wanted to put this in scientific notation, you would move this to the left twice. And anytime you're moving to the left, this number needs to get larger I say larger because it's weird with negative exponents, so this would be 3.5 times 10 to the negative 7th. My introduction to scientific notation video explains this, but basically these are all saying the exact same thing. This is something that you could practice, is just give yourself a number and convert it to as many different units as you can. All right, we'll do one other quick example. We will do one with milliamps. Let's say that you have 2.5 milliamps and you're trying to, actually no, we're going to go opposite direction. Let's just say that you have 2.5 amps and you need to get to a certain number of milliamps, right? There's that little prefix milli. So this time, again, ask yourself, is the number supposed to be getting larger or smaller, right? So amp is a larger unit of measurement than milliamps. So there's going to be more milliamps than there are amps. Basically, the number should be getting bigger. So here, the exponent for milli is always 3. And specifically, we're basically going to be multiplying 2.5 amps is equal to 2.5 times 10 to the third milliamps. These are the exact same thing. They are saying the exact same thing. They are represented by the exact same number. They are the exact same, right? Okay, so because of that, we'll do one final example of when things get a little bit weird. Because maybe they give you nanometers. Let's just say that they give you 600. We'll do micrometers just to have done all of the units. We'll do microliters, actually. We'll swap out meters for a different unit. So let's just say that you have 600 microliters, and they're asking you to convert this in the answer choice to some number of milliliters, right? They're asking you to go from micro to milli, right? So micro, its exponent is going to be 10 to the 6th. Milli's exponent is going to be 10 to the 3rd. So we're going to be changing by a factor of 10 to the 3rd, right? This number decreases by a factor of 10 to the 3rd. So basically, you just have to ask yourself, if we're going from micro to milli, is that unit getting larger or smaller, right? Micro is a smaller unit than milli, so when we write the number in milliliters, the number should be getting smaller, right? So basically, all we have to do is take this number of microliters. I'm going to rewrite the micro as 10 to the negative 6th. Or actually, sorry, I lied. No, we're going to do it this way. We can basically just take this 600 microliters and multiply it by 10 to the negative 3rd, how much it changed by. That's going to give us 600 times 10 to the negative 3rd milliliters. Right, so we could simplify this if we wanted to, but basically these two numbers, 600 milliliters and 600 times 10 to the negative 3rd, 600 microliters and 600 times 10 to the negative 3rd milliliters are the exact same number. We just have now converted it into the number that the answer choice might be looking for. One final example of this, we will go from nano. We'll go from centi to nano. Let's say that they give that something is 2 centimeters, and you, for some reason, need to convert this to nanometers. This is not something that they're really going to make you do on the MCAT. We're getting, for the most part, most of these conversions will always be from some SI prefix back to the base unit, like millimeters back to meters, something like that. But maybe if you can do something like this, this is basically just evidence that you're comfortable with it. You're going to be fine, basically. So centimeters has the exponent of 2, depending on if it's going to be bigger or smaller. That's just what's going to determine if it's negative or positive. And nano is going to be 10 to the 9th power. So notice that the difference between these two is 10 to the 7th power. So you just have to ask yourself, is the unit getting bigger or smaller? The unit is getting smaller, so the number is going to get bigger. So because of that, we take 2 centimeters and we multiply it by 10 to the 7th power. And that is going to give us that number in nanometers. We have 2 times 10 to the 7th power nanometers. And that's your answer. These two numbers, 2 centimeters and 2 times 10 to the 7th nanometers, are the exact same number. Right. So that's just a quick introduction on how to make the SI prefixes easier to use. We're just going to list out the final two prefixes that you need to have memorized. Just as to finish the circle, essentially, there's two SI prefixes that actually go the opposite direction in that they are a larger unit than the standard unit, like for meters, which would be 10 to the 0th power. So like I said, still using meters as an example. I don't know why I put so much space in between meters and the rest of that. I'm going to slide that over. That's going to bother my OCD a little bit. Okay, so using meters as an example, there's going to be two units here that are actually larger than a meter. The first one is called a kilo, a kilometer. The prefix K, and the next one is a mega, which confusingly is also an M, just like milli, and micro is mu, which kind of looks like an M. Excuse me. Mega is going to be a capital M, right? A megameter is not really something that we ever see in our world, our real world, but they do exist. It is a thing. It's basically just telling you a different way of organizing meters. So we'll start off with the one that you're probably more familiar with. We're going to start off with kilometers. So same thing. When we're going from a kilometer to a meter, is the unit getting smaller or bigger? In this case, it is getting smaller, so the number is going to get bigger. Right? Notice that this is a little bit opposite of the direction of the arrows that we had on the last slide, where before, when we were going to meters, the number is going to be getting smaller, but now the number is going to be getting bigger because meter is a smaller unit than kilometer. Right, so the prefix for kilo is 10 to the 3rd power. So here we will be multiplying kilometers by 10 to the 3rd power, or in other words, the number is going to be getting bigger. To get to meters. If we need to go the opposite direction, if we're trying to get from meters to kilometers, wrong color, then we will just be multiplying by that same exponent, just negative. The number is going to be getting smaller. Right, so as long as you just have these exponents memorized and know what the units mean, you're going to be perfectly fine. You're going to be able to do all of these conversions pretty easily. There just is some memorization that's required. Obviously, in my MCAT course, we're going to be doing a whole bunch of practice with this just to make sure that you're really comfortable with these SI prefixes. So same thing with mega to just the standard unit. Anytime we're going from mega to its base unit, in this case, we're talking about meters as the example. Realistically, on the MCAT, you're probably only going to see megawatts. Watts is the unit of measurement of power. Maybe megajoules, but probably not. So megawatts, that would just be 10 to the 6th power watts. In other words, we are just multiplying this number by 10 to the 6th power because the number should be getting bigger. And if we're going the opposite direction, we're going to be multiplying by the negative exponent. The number is going to be getting smaller. So once I've added in that arrow, that's pretty much it for the SI prefixes. We're not going to do any practice here because it's basically the exact same thing that we did a second ago, just with different prefixes instead of nano and kilo and that sort of stuff. If you do need more practice or you do need other math practice, I highly recommend signing up for my math and equations course that I have. That's linked in the description. If you're watching this sometime in January of 2026, that's not yet out, but it should be out sometime within the next month. So I highly recommend either signing up for it or if it's not available yet, signing up for updates. Appreciate you all watching. Hopefully this was helpful. Obviously, this is going to be really beneficial in combination with a lot of the other videos that you might be watching from me, but hopefully we're just using this to make your life a lot easier for the MCAT as far as the math is concerned. So I'll see you guys in my other videos, and good luck with everything. Good luck with your math, etc., etc., etc. Hopefully you are at least getting a little bit more comfortable with some of the MCAT stuff, and I will see you guys in the next video.